All right, let's just get right into it. When we look up at the night sky, it's so easy to think of the cosmos as this permanent, unchanging thing. But right now, we're actually witnessing the final days of literally one of the most iconic features in our entire solar system. I'm talking about Jupiter's Great Red Spot. This majestic 350-year-old storm is dying. But throughout this explainer, we're going to see why the fading of this colossal alien storm isn't just some sad loss for astronomy, it's actually a vital key to humanity's survival. So here's our roadmap for today. First, a disappearing giant. 2, inside the Great Red Spot. 3, decoding Earth's climate models. 4, securing global food supply. And finally, the closing cosmic window.
Part 1. A disappearing giant.
Just wrap your head around this number for a second. 1,300. You could literally fit 1,300 of our tiny Earths inside Jupiter. It's an absolute behemoth. I mean, it's 2.5 times the mass of all the other planets in our solar system combined. Mostly made of hydrogen and helium, it's this awe-inspiring planet of extremes. In fact, if it had managed to grab just a little bit more material during its formation, it could have ignited into a star. Imagine that! In some alternate reality, we might be living in a binary star system right now, kind of like the double suns on Tatooine. But instead of a second star, we ended up with a gas giant that just spins furiously. I mean, 43,000 kilometers per hour at the equator. That is 28 times faster than Earth. A single day on Jupiter is over in just 10 Earth hours. Because it's spinning faster than literally any other planet in our neighborhood, that intense, blisteringly fast rotation sets the absolute perfect stage for the most extreme weather humanity has ever witnessed. Part 2. Inside the Great Red Spot. Okay, so to really understand what the Great Red Spot actually is, we kind of have to look at how it totally differs from the storms we get here at home. So on Earth, our cyclones generally form around columns of rising air that are driven by low pressure. But Jupiter plays by its own rules. The Great Red Spot is this massive, high-pressure anticyclone. It forms around columns of air being forced downward, and this incredibly rare structure creates a gigantic vortex that fully rotates counterclockwise once every 6 days. And just to illustrate how violent this anticyclone really is, let's talk wind speeds. The absolute fastest cyclonic wind we've ever recorded on Earth was Cyclone Olivia, which topped out at a terrifying 408 kilometers per hour. But the Great Red Spot? Its winds howl at speeds pushing 700 kilometers per hour. That extreme turbulence actually produces acoustic waves that physically heat up the gases above the storm. It is just an engine of absolute chaos. But the data is showing us that this engine is finally running out of gas. Back in the 1800s, scientists estimated the storm was roughly 48,000 kilometers wide. That easily swallows 3 Earths side by side. But today, it's shrunk down to barely over 16,000 kilometers. And it's not just shrinking, it's physically changing shape. It used to be this stretched out, elongated oval, and now it's becoming much more of a circle. That is a clear-cut signal that the storm isn't just losing its size, it's losing its fundamental structure.
So you're probably wondering, how on Earth, or how on Jupiter, did it survive this long in the first place? Well, the secret lies in the Coriolis effect. Jupiter's atmosphere has these incredibly distinct bands flowing in opposite directions near the equator. So the Great Red Spot is essentially just a ball trapped right between these huge, opposing atmospheric conveyor belts. Those countercurrents act exactly like a vice, sustaining and spinning this vortex for centuries.
Part 3. Decoding Earth's climate models. Now, it's really easy to look at everything we've just covered and say, wow, okay, cool space trivia. But I want to pose a real question directly to you. If this giant storm, sitting 600 million kilometers away, completely vanishes, what difference does it actually make to us here on Earth? Does it even matter? The answer is a massive, resounding yes. And it all comes down to a meteorological concept called atmospheric blocking. This happens when large, high-pressure weather systems essentially get stuck in one place, totally preventing normal atmospheric movement. Now, what does that have to do with Jupiter? Well, by studying how the Great Red Spot, which, remember, is a massive, incredibly long-lived high-pressure vortex, sustains itself against all that surrounding turbulence, scientists were actually able to gain the exact theoretical tools they needed to study these stuck high-pressure systems right here on Earth. And the crucial takeaway here is that this isn't just some abstract academic theory. It has real, on-the-ground consequences. When atmospheric blocking locks up over Earth's continents, That lack of movement causes incredibly severe stagnant weather patterns. We're talking about extreme, deadly heat waves that bake entire regions for weeks on end, or prolonged cold spells that completely freeze vital infrastructure. The geophysical fluid dynamics that we learned from observing Jupiter translates directly into understanding our own volatile skies.
Part 4. Securing global food supply.
So let's look at how this advanced understanding builds into real-world action. Because we've refined our understanding of the Coriolis effect and atmospheric blocking by observing the Great Red Spot on this massive scale, food security modelers can actually predict these blocking events weeks in advance. Here's how the pipeline actually works in practice. We observe the atmospheric blocking forming. Governments then issue early heat warnings. Farmers on the ground take that info and adjust their harvest schedules. And ultimately, we prevent mass crop failures across multiple continents. Just to give you a real sense of the massive stakes involved here, think about this. Without those predictive models directly informed by that alien storm, just one unlucky set of blocking events could cut global food production by 3% in a single year. 3%! That equates to millions of tons of food suddenly just vanishing from the global supply chain. So the data we extracted from Jupiter quite literally helps keep food on the table for us here on Earth. Part 5. The closing cosmic window. You know, cosmic data gets deleted silently all the time. Think back to 1665. The astronomer Cassini tracked what he called a permanent spot on Jupiter. But after his records, a definitive spot wasn't actually seen again for another 166 years. Was it the same storm? Did it collapse and reform? We will literally never know. That data is just gone. Similarly, we observed a great dark spot on Neptune back in 1989. 5 years later, completely vanished, just gone, before we could derive any meaningful signs from it at all. The reality is, if we don't capture this cosmic data while it's there, the knowledge is lost forever. And the scary part? This erasure is happening to the entire universe. Thanks to accelerating expansion, galaxies are moving away from us faster than the speed of light. If you fast forward 2 trillion years from now, any civilization that evolves then is going to look up into their telescopes and just see an immense nothingness. Even the cosmic microwave background radiation, which is our absolute clearest evidence of the Big Bang, will have redshifted into undetectable oblivion. They're going to have a fundamentally flawed cosmology because the evidence will quite literally be deleted from their night sky. But we didn't evolve 2 trillion years from now. We are incredibly, profoundly privileged. As our source material so beautifully puts it, we evolved in this narrow, fleeting window of cosmic time, where the universe is old enough to form life, but young enough that the evidence of its history is still legible. We are technologically advanced enough, right now, to extract life-saving, weather-predicting data from a storm 600 million kilometers away, right before it disappears forever. It really does make you appreciate the exact moment we live in. So I want to leave you with this final, somewhat provocative thought to ponder as we wrap up this explainer. When the universe inevitably erases its own history, what fundamental truths will future civilizations completely misunderstand, simply because their data window closed? Thank you so much for exploring the cosmos and its really profound connection to Earth with me today.